Okay, so this is actually what I'm thinking you probably have experience with. So say you have a proportion and you're missing one piece of it. Then we use the cross product property to solve. Okay, so we're going to multiply those two to get 7x, and these two to get 60. And you don't have to show the extra step, but I always feel like in the notes I shouldn't do too much to the step that I'm on, because if people go back and miss what's happening. So we have this. What do I do to that to finish it up and find x? Yeah. Divide out 7. Now here's the thing. Okay. At each level in high school math, you're held more accountable for how you leave your answers. You're held accountable for rounding in units and that type of thing. Make sure, okay, you can check, you can take your calculator and see if 60 goes into 7. If you get a non-terminating decimal, your next step would be, okay, I don't want that, I'm going to leave it as a fraction. The next question is, can I simplify it? Does anything go into both 60 and 7? If the answer is no, then you're going to leave your answer just like that, okay? So you can leave it as a simplified improper fraction, but I don't want you, unless the directions explicitly say round to the nearest 10th or 100th, we don't want you rounding. We leave it as precise as possible unless you have a reason to turn it into a decimal. Okay. In real life, some things are going to be more useful in decimals than the fractions. All right, but for our purposes, we're going to leave it just like that. Okay, so another one, this is the one more people tend to mess up on. Okay. All right, so this is what would be staring you in the face. Okay. I almost started to put them in because it's habit, but with a quantity, you're going to use parentheses. Okay, so if you have more than just 4 values, you're going to throw parentheses in on the quantity. So the first part is just going to be 8y. But the second part, that's why you use your parentheses. Most people that don't put the parentheses in forget to distribute. They multiply what's closest and call it good, and that's not what you want to do. This is actually 4 times the whole quantity. So we have 8y would equal what? Yeah. Make sure you distribute, and then the rest is just algebra. I mean, not that that's not, but. So we have 4y equals 12. So y would be 3. And if you're sitting there and you have a test or a quiz and nothing to do after the test and the quiz, and you're looking going, I have 10 minutes, I could sit like a lump, or I could check my answers. You could go through and check your answers and know whether or not they're right. Because if I plug 3 in, I get 6 over 8, and I get 3 over 4, and is 6/8 equivalent to 3/4? So you could check that. If you plug it in, and if you're not sure, say you get 2 fractions, and you're like, well, I don't know if this one's equal to that, you could turn them into a decimal and see. They would have to be the exact same decimal, but you can check them. There's no reason to get those wrong. All right, so last concept, and then we're going to do 2 homework problems. Our are scale drawings. A scale drawing compares length in a drawing to length of an original. So, can someone give me an idea of where you might see a scale drawing? What's that? So, blueprints, right? Whether it's architecture or just someone who works in construction, they use blueprints. So you've got both ends of it, the person that actually designs it and the person that carries it out. Different ends of the spectrum there. Not as prevalent as they used to be because of GPS, but maps. Okay, maps are scale drawings. And it's not a drawing, but we could also throw in there anyone who, like, you have collectors or people who like the scale models of things. You know, you've got NASCAR people who, you know, sometimes buy the scale models of the cars, you know, collector's items. So we'll throw that in there even though it's not a drawing. If you have a scale model, that's like taking that item and shrinking it down, okay, on a copy machine or things like that. Now, the thing that you'll learn as we go through this chapter is if I threw something on a copier, my segment lengths, they're going to be proportional. Say I reduced it by 1/3. Every length is going to be reduced by 1/3, right? But do my angles change? My angles don't change, so that's why when we said in the congruence chapter, you can't prove triangles are congruent with angle, 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 but we can prove similarity. If all the angles are the same, then the shapes are at least similar, so we'll get into that this chapter as well. So say you have a blueprint, and the length of the bedroom in inches is 7/8. And the scale is that 1 inch equals 16 feet. Okay. Now you might find this very annoying, okay, but there's method to my madness. Most people are going to just bust out their calculator and multiply, okay? That is fine and dandy if the scale is 1 equals something else, right? If 1 inch is a certain amount of feet, it will work. You will get the right answer, okay? I'm going to be looking for the proportion though, and here's what I'm talking about. You're going to take that scale and set it up in 1 fraction. So we have 1 inch over 16 feet, okay? So you're going to put the scale in 1 fraction. In the other fraction, you're going to set up the units the same, inches over feet, and you're going to plug in the measurement that you have. And that's why we use the units. So if they gave me 7/8 of an inch, where's that going to go? Now don't get confused. This is a fraction, and yes, that's a fraction, but this is only your inches. We're looking for the feet, right? So that, being inches, is going to go in on top of your fraction. The real length will be in feet. We don't know what that is. We're looking for it. Now, the fact that you can set this up, okay, You could have done this probably with a calculator without setting up the proportion, but if the scale were 2 inches is 12 feet or whatever, 2 inches is 7 feet, okay, then you don't have that. You're going to have to set up a proportion and do it. Okay, so here, don't worry about the units. You're not going to multiply those. They'd work themselves out anyways, as long as you have inches, feet, inches, feet. Just going to multiply the values. So we have x equals 7/8 times 16. Okay, the long way of doing this, which is what most people do at this point, you can always put this over 1, if it's a whole number. You would multiply the tops and the bottoms and then go on and simplify. Okay, so you don't have to do that. I'm going to show you why in a minute, but we'll do it to humor you. So that would be 1/12 over 8, and then you'd have to simplify that. But when you're multiplying two fractions, even though 7/8 doesn't simplify, 16 over 8 simplifies, and you can do that first. So if you don't have a calculator handy and you don't want to mess with 7 times 16, but you go, hey, 8 goes into 16, I would do 16 divided by 8, which is 2, and 1 on the bottom, right? You're basically simplifying 16 over 8. And then 7 times 2 is 14, which is what 1/12 divided by 8 is. And I didn't have to use my calculator. Does that make sense? Yes? No? If you guys get 14, I don't care if you do that way or that way. I'm just trying to give you a calculator not needed method for it. Okay, and because this is real life context, you don't want to forget your units. We just solved for x, which was feet, right? So it would be 14 feet. Make sure you include those. You can be marked down without them. All right, so there are 2 problems off of the homework we're going to do, and the rest you're on your own. We're going to do number 2. It says the Leaning Tower of Pisa in Italy is about 185 feet tall. A model of the tower is 6 inches tall. What's the ratio of the height of the model to the height of the tower? So we're going to go model to tower. So we have 6 inches to 185 feet, and based on what you wrote in your notes, what's the first thing I should be concerned with? Yeah, we have feet in inches. Now this is a case, and this I'm going to show you, this kind of takes care of the whole fraction issue. You could convert 185 by multiplying it by 12, but then you're going to have big numbers to simplify at the end. Okay. Now on the other hand, 6 inches is a half of a foot, right? Okay. I would go with the half of a foot, and I'll tell you why. You've done this before with equations. How do I get rid of a half? Multiply by 2. Okay, easy to get rid of that. So, but whatever you do here, you have to do it to the other, kind of like if you divide out part, you do from both. So we're going to multiply both sides by 2. So 2 times a half is 1, and 185 times 2 is 370. And that is the ratio. And 29 is a similar ratio problem. I think you guys will do fine with the others, but people always tend to have trouble with this one. Diameter of a dinner plate is 1 foot, of a real one. Diameter of a dollhouse plate is 1 1/4 inch. And They want the ratio of the dollhouse to the full size. So, order first, at least get it in there. So the dollhouse is 1 1/4. The dinner plate itself is 1 foot. Okay, so first thing I need to do would be what? Units, are they the same?
Inches.
I would go with feet to inches in this one. We have 1 foot, so we're going to make this 1 1/4 and 12, so they're both inches. Okay. Now, the whole fraction thing, you just follow these steps. If it's a nice fraction, turn it to a decimal, but you're going to want to note what that denominator is because it's going to help you get rid of it. Okay? So 1 1/4 is really 1.25, yes? Can't leave the decimal there, but it was a fraction. It was a fraction with a denominator of 4. This just saves you from having to turn it to an improper fraction. You could do that if you wanted, but if I multiply both sides by 4, since the fraction part of my ratio was a 1/4, it'll get rid of it. So we're going to do both sides by 4. So this will be 5, and this will be 48. And this particular problem in the book was multiple choice, and your options were 5 out of 48, 4/5, 5/4, and 48/5. So which option would be the correct one?
5/8.
Yeah, the first one, because the order, that goes on top. So it'd be this one. You can see by the other choices, they took care of the fraction, but didn't, well, they got the 5 and the 4, but somehow, oh, they used 1. So they used this and multiplied both sides. They didn't change it to the units. So that's where they came up with those possibilities. All right, so that is the correct one. So I am going to put up the first page so you can quickly